Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 13, 2025, about 4 days ago. This paper surveys how to overcome core LLM limitations, like hallucination and poor reasoning, by creating systems that dynamically combine knowledge retrieval with deep thinking. The paper is titled, Towards Agentic RAG with Deep Reasoning, a survey of RAG reasoning systems in LLMs. And as we'll see, this synergy allows AI agents to achieve state-of-the-art performance on really tough problems. The authors map out an evolution of these techniques, from simple enhancements to fully integrated frameworks. Also, the authors shared their work on GitHub, and it's a fantastic resource. They've put together a curated, awesome list, bringing together a huge collection of papers, tools, and benchmarks that bridge the gap between RAG and reasoning. It's a great starting point for anyone exploring this field. Alright, so to really unpack this, the authors provide a fantastic visual map of these systems. It shows 3 main stages of development. First, you have one-way streets, either using reasoning to improve Retrieval-Augmented Generation, which is the process of fetching external data to ground an LLM's answer, or doing the reverse, using that retrieved data to enhance the LLM's reasoning. But both have drawbacks. The real breakthrough, shown at the bottom, is a two-way synergized system, where reasoning and retrieval happen iteratively, constantly improving each other in a loop. And this figure really lays out the details of that evolution. You can see the 2 one-way approaches at the top. First, reasoning enhanced RAG, where the model's thinking improves its data retrieval. Then, RAG enhanced reasoning, where retrieved data improves the model's thinking. But the most advanced stage is at the bottom, the Synergized RAG-Reasoning. This approach combines different reasoning workflows, like chain-based or even tree-based thinking, with what's called agent orchestration, which is basically how the AI system is organized, using either a single agent or multiple agents working together. So to measure how well these advanced agent systems perform, you need the right kinds of tests. This table gives a great overview of the key benchmarks used for evaluation. It organizes them by task, from web browsing and coding to really complex question answering. For instance, it includes multi-hop QA, which is where a system must find and connect facts from multiple sources to form a single answer. The table also shows the different kinds of reasoning tested, like deductive, which is reasoning from a general rule to a specific case, highlighting the diverse skills these systems need. Okay, so this next table dives into the how these advanced systems are actually constructed. It compares different approaches based on 2 key aspects, reasoning workflow and agent orchestration. The reasoning workflow is essentially the model's thinking style. This could be a linear, chain-based process, a branching tree of thought that explores multiple possibilities, or a graph-based method that connects information like a web. Then you have agent orchestration, which is how the system is organized, either as a single agent or a multi-agent team, which can be coordinated or decentralized. So bringing it all together, what we've seen is a clear evolution. We've moved from one-way enhancements to a truly synergized system, where reasoning and retrieval are deeply intertwined. This iterative loop is the key. It's what allows these agentic LLMs to tackle complex problems with better factual grounding and logical coherence. Of course, challenges remain, like making these systems faster and more trustworthy against things like adversarial attacks, which are attempts to trick the AI. But the future of capable, reasoning AI seems to lie in this tight coupling. Thanks for tuning in.